Now silt, it's kind of a medium textured, medium infiltration, medium water holding capacity type soil. And oh, by the way, clay also has a really high water holding capacity. Intake rate, and then we have water holding capacity. And its water holding capacity can be like 3 inches per foot. You get a clay soil, you could actually hold 3 inches of water in a foot of clay soil. You could be, that much water could be stored. If you were to squeeze it out of there, you'd take a square foot and squeeze all the water out of it, you'd get a square 3 inches deep full of water out of a pretty typical clay soil. It'll hold a lot of water.
It's hard to get it down.
Now it's real hard to get it into the soil, but once it's there it'll stay, and it's also real hard to pull it away because those clay soils really like to hold on to that water. There's a molecular bonding that occurs called cohesion, and it wants to cohere water to the clay particles, so it doesn't like to give it up very easy. So the plants have to work pretty hard to pull water from it. And also it takes quite a bit of energy for it to evaporate out of it too, because it doesn't want to give it up. There's a lot of soil tension holding on to that water. Now that silt soil, its intake rates usually around 0.10 to about 0.3 inches per hour. Now we get pretty typical infiltration rates for what most typical agricultural systems are designed for if we're looking at solid set, hand line, wheel line styles. And they've designed those systems obviously to try to be amenable to the soil type that they're irrigating. They want to put on 0.25 of an inch an hour because that's the fastest the soil will take it in. Okay, that's what they designed for. So they're designed accordingly. Again, in turf, we're generally going to put water down faster than this value. And we use a lot of irrigation on turf on silt soils. The twist is with silts and turf is that we water turf very regularly, maybe every day, maybe every other day. We don't have to put a lot of water on at a time. And so we get away from having to water for a 12-hour set or a 24-hour set and constantly apply water because our intake rate starts to get all goofed up in that process. And in here a ways, we're going to talk about the intake rate. Of soil, so we're going to get to that, and I'll show you representative what happens with sand versus silt versus clay. Now sand soils, sandy soils, they're very coarse textured. And they can have intake rates, now we're going up to 1+ inches per hour. Now this water holding capacity in silts, oftentimes they'll hold 2 to 2.5 inches per foot. Sands, well, we don't do quite so well with sands. Sands drop down there into, in fact, this could even be maybe up to a little higher or maybe a little lower. Silts are a wide range. Sands, they don't hold water near as well, usually somewhere less than 1.5 inches per foot. And again, generalizations. And of course there's a wide gradient across there. One given texture of sand will have a different characteristic than another given texture of sand. And as you read soil reports, they'll all have a name. Like we got, for example, around here, Walla Walla Silt Loam, the most popular soil here in the area. And then you just go a little bit east of town and now all of a sudden becomes Palouse silt loam. Is there much difference between those two soils? Not a whole lot. They're almost identical, but there is a slight variation in their makeup. And so they're classified slightly different. Go to the west of town, we get Catherine silt loam. Again, is there much variation between Catherine and Walla Walla? Not very much. Between Walla Walla and Palouse? Not very much. Between Catherine and Palouse? More. Walla Walla sits in between the two. There's just a difference in the amount of fines versus the bigger particles in them. The Catherine silt loam's has a little more larger particles than does the Palouse silt loam. And Walla Walla silt loam sits in the middle of them there somewhere. But they still fall in the category of a silt loam. But we get into some of the blow sand over in the Columbia Basin, and it's virtually, you talk about intake rates, you take a bucket and start pouring the water on it, and it'll just take it as fast as you can pour the water on it. Just like if you go to the beach. Most of you have gone to a beach, a sandy beach, you take a bucket of water and pour on it just disappears. It's gone. Well, that's very typical of these blow sand areas that we will find in a lot of the agricultural area up in the Columbia Basin. Particularly on the west edge of Walla Walla County. There's a number of areas where there's a lot of fine sand soils that are very, very sandy. Nothing else there. You know, it's just about pure sand. And those suckers don't hold much water at all. It just drains right through about as fast as you put the water on it. So obviously when we have those kind of soils, we have to be able to irrigate very frequently. We run into that exact same soil type on every USGA spec green we run into. We got 14 inches of sand. And below that, 4 inches of pea gravel. So boy, we are creating a very rapid infiltration rate and intake rate through that soil. Now we mix like 10 to 15% organic in there just to have something to hold the nutrients and to slow some of that water down and hold it in place. But you're looking at 85, 90% mason sand, washed mason sand with about a 10 to 15% blend of organic material. It's kind of like ground up bark dust is what it amounts to. And you blend that all together and you have yourself a very porous piece of soil to work with. And obviously we have to water greens every day in the summer, sometimes twice a day, sometimes even 3 times a day in certain spots when it gets super hot. Because there's no storage. That water doesn't store, it's gone. No water holding capacity at all. It just pours right through there.
Put a little peat moss on top or something like that.
Well, that helps keep the evaporation down. Sure.